Hi everyone, we're going to do an inclined plane problem from chapter 4, so here goes nothing. A 15 kilograms box is released at a 32-degree incline and accelerates downward at 0.300 meters per second squared. What is the frictional force impeding the motion of the box, and what is the coefficient of kinetic friction? Let's start by drawing a picture of my inclined plane. So here's my object. On the inclined plane, we're going to draw a little dot. We're going to draw all the forces acting on the object. And let's sum all of our forces. So force of gravity always acts straight down towards the center of the earth. Normal force, perpendicular to the surface. Boy, I kind of missed my dot, didn't I? Force of gravity impedes motion. Frictional force impedes motion. It's going to go back like that. It does not say that there are any additional forces pushing on the object, so those are the only forces acting on it. Now remember, one of the things we want to do is we want to get all of our forces parallel and perpendicular to the incline. So frictional force, normal force, those are parallel and perpendicular to the incline, but gravity is not. And so we are going to break the gravity vector into components. So I'm going to drop a perpendicular from the normal force. And then I'm going to draw up another force that is parallel to the incline and a force that is perpendicular to the incline. And there's my little right angle right there. Now this is a 32-degree angle, and this 32-degree angle happens to be equivalent to the 32-degree angle right there. Very convenient and very handy. What else do I know? The rate of acceleration is 0.3 meters per second squared. We know the mass of the object is 15 kilograms. We're looking for the force of friction, and we are looking for the coefficient of friction. So first thing we're going to do is let us sum our forces parallel and perpendicular to the incline. So the forces parallel to the incline and sum the forces perpendicular to the incline. Now in each direction you ask yourself the question, do they equal 0 or do they equal ma? Parallel to the incline, in the direction of the inclined plane, do they equal 0 or ma? Well, we're told the object is accelerating. So parallel to the incline, it is going to equal ma, Newton's second law situation in that plane. Perpendicular to the incline, it's going to equal 0 because of the fact it's sitting on the incline. It is not falling through it or rising above it, launched into space. Next, we are going to draw our forces in each direction. So parallel to the incline, we have the friction force going back, and we have the force parallel. Perpendicular to the incline, what do we have? We have normal going up, and we have the force perpendicular going down. Those are the only two forces in that direction. So let's draw our equations. Force parallel, and let's call everything down the incline positive, and any force that goes up the incline, let's give that a negative value because it's opposing motion. So force parallel to the incline, here's what we've got. I've got my force parallel minus the force of friction, because it's opposing motion, is going to make my mass accelerate. So force parallel minus the force of friction is going to make my mass accelerate down the incline. Forces perpendicular equals 0, so the forces up are going to equal the forces down, or my normal force will equal my force parallel. Okie dokie, here goes nothing. Now, force parallel, what's force parallel going to be? Well, force parallel is the opposite side of this equation. So force parallel is going to be, and you can do this up in the triangle or you can do it down here just for space. I'm going to do it down here. Force parallel happens to be the opposite side of this vector triangle, where this side is the force of gravity. So force parallel is going to be my force of gravity, my hypotenuse, times the sine of 32 degrees minus my force of friction. And what am I going to replace force of friction with? Mu times normal force is going to be equal to my mass. What do I know for mass? 15 kilograms times my rate of acceleration, 0.3 meters per second squared. And I'm just going to carry this equation down as far as I can go, and when I get stuck, then I'll move to the other side. Okay, let's keep it going. Force of gravity, I know, is mass, which is 15 kilograms, times the acceleration of gravity, 9.8 meters per second squared, times the sine of 32 degrees. So I'm just expanding this to give it me all of this, minus mu, I do not know mu, times the normal force, don't know that yet, equals 15 kilograms times 0.3. So let's do that. 0.3 times 15. So this is 4.5. What unit should be on that? Kilograms times meters, second squared, newtons. What does all of this end up being? Well, let's see. The sine of 32 times 9.8 times 15. All of this ends up being, I'll keep it to 3 sig figs, 77.9 newtons minus mu times normal force equals 4.5 newtons. Now this is as far as I can go on this side without more information, which is the normal force. So now I'm going to go to my other column of information and solve for normal force. So I'm going to pull this down. Normal force is going to be equal to force parallel. Well, force perpendicular. I wrote the wrong thing. Okay, I paused because I knew I had made a boo-boo. Force perpendicular is right here, right there. And if you were yelling at me, I apologize. I just heard you. I'm a little slow. Okay, force perpendicular is this side of the triangle. Let's take a look back here to make sure we're all communicating. I heard you. Sorry, it took me a while. This is going to be equal to that. So this is the force perpendicular to the incline. This is the adjacent side of this vector triangle right here. So that is going to be equivalent to the force of gravity times, because it's adjacent side, cosine of 32 degrees. Normal force, then, force of gravity, can be replaced with mass times acceleration of gravity times the cosine of 32. I know my mass is 15 kilograms. Gravity is 9.8 meters per second squared, times, of course, cosine of 32. I know, I'm squishing things off the edge of the page. All right, let's replace all of that here. So cosine of 32 times 9.8 times 15. So this ends up being 125 newtons for my normal force. Now that I have normal force, I'm going to shove it back up here. And normal force is going to be that. So I'm going to end up with 77.9 newtons minus mu times 125 newtons equals 4.5 newtons. I can solve for mu. How am I going to solve for mu? Well, I am going to subtract 4.5 from both sides. So subtract 4.5 newtons from both sides. And I'm going to add mu times 125 newtons to both sides. I'm going to add mu times 125 newtons to both sides. What that's going to end up with is, grab a calculator, 77.9 minus 4.5. On this side, I'm going to end up with 73.4 newtons equals mu times 125 newtons. To get mu alone, I'm going to divide both sides by 125 newtons. Mu divided by 125 newtons. So mu is going to be equal to I get for mu 0.587. That's going to be equal to, there's no units on mu. I was having a moment of wackiness. So that's going to equal my mu. So what am I going to get for my friction force? Friction force then is equal to mu times normal force. Well, that's going to be 0.587 times my normal force of 125 newtons. So that times 125, I end up with a friction force of 73.4 newtons is friction force. Could have done it in slightly different order. I just happened to do it this way on this day. All right, have a good one. See you later. Bye-bye.